What's up, everybody? Welcome back to another live stream from the Scalar Learning Channel. And today we are in test week. This is it. The SAT is this Saturday for both international and domestic students alike. And I've been really trying to do a stream almost every day leading up to this test. It hasn't been easy. It's a busy time, but I know it's super important for you guys, so I'm trying my absolute best. Thank you so much for joining. The reason why I'm doing this stream so late, it's almost 11 o'clock here in LA, is just because how busy my day was. I literally just finished teaching a few minutes ago, so I figured now was, well, it was the only time I could do it, is either now or never. So we're doing it now. And that's it. So let's go for all of you folks getting ready for this SAT. Now, I'm doing the digital SATs. By the way, if you're taking the regular paper version of the SAT, I got tons of videos on past tests and things like that. But from a subject matter perspective, it's pretty much the same. There's like a couple nuances and little differences that I've seen here and there. You can't use the Desmos calculator. I'll be using that today on this test. But otherwise, from a conceptual standpoint, it's pretty similar, so this should be good whether you're taking the domestic or international. But I will be redoing some of the old recent tests later this week as well for the U.S. students, just the regular ones on paper. So you'll get those as well. Just trying to make it all work here. We got a lot going on, and watching your video from school. Love your videos. Yo, what's up, Vedant? Awesome. Hey, what's up, David? What's up? Hi, thank you for reveal answer that I confused. You're welcome. Okay, so ladies and gentlemen, tonight we're just doing Module 1. I'll probably do Module 2 tomorrow. Still haven't figured out when. Truth be told, I need to catch up on a lot of sleep, so I'm kind of sleeping in, and then we'll go from there. Now, if you haven't joined our Discord community, it's free. It's in the description link below. I highly encourage it. There's tons of students on the Discord community that help each other, form study groups. It's really cool. I post a lot of times when I'm going to live stream in there, so you should definitely do that. We've also got a video course if you want to check that out. It's $15 a month. You can buy it, cancel it, whatever, if that's helpful for you. What's up, Daily Solutions? And if you like the video, or if you like me and you like what we do here, make sure to click that like button. Obviously, feel free to subscribe. All right, without further ado, let's do this thing. Here we go. Module 1, practice test 3. I have seen the PDF version, but I've never seen the digital version. I think it's slightly different, so this will be fun. All right, 3, 2, 1, let's do it. A bus traveling in constantly along a straight portion of the road. The equation D equals 30t gives the distance in feet from a road marker that the bus will be t seconds after passing the marker. How many feet from the marker will it be 2 seconds after passing the marker? So this is a straight plug and chug situation. 2 seconds, 2 plugs in for t. 2 times 30 is 60. C is the winner. Boom, done. All right, number 2. A line in the xy plane is a slope of 1/9. Hold on, let's get it over here. We got a slope of 1/9 and passes through the point 0, 14. Guess what? 0 is the x value. That means that's a y-intercept. So I can straight up put this into slope-intercept form like so. Which equation represents this line? Positive 1/9, so it B and A are out. And plus 14, D is the winner. Boom, done. Number 3. If x over 8 equals 5. All right, let me show you how to do this. Of course, you could just say 1/5, but we're going to do it nice and straightforward, so there's no guessing. Look, this is a equation, right? So let's solve for x first. Multiply by 8. We get x equals 40. And then they want 8 over x, which would be 8 over 40, which of course reduces to, as we said, 1/5. Now, how did I know it was 1/5 right off the bat? Because x over 8 is the reciprocal of 8 over x. So we just take the reciprocal of 5, which is 1/5. But either way is fine. All right, here we go. Boom, done. Number 4. Triangles ABC and BDF are congruent. What does that mean? That means they're identical. Okay, so we'll just make some 2 triangles. Here we go. A, B, C, and it says A corresponds to D, which we kind of already know based on the congruent statement. A, B, C, D, E, F. It's usually in that order. So B corresponds to E. C corresponds to F. Oh, shoot, they're right angles. Okay, let me redraw this. I want to be a little more accurate. Believe it or not, Miro doesn't have right triangles, so I'll have to draw this one by hand as quickly as possible. Boom and boom, and let's copy and paste. Boom, boom. Okay, and we've got where's the right angles? B and E, those are our right angles. And then they said A corresponds to D and C corresponds to F. The measure of angle A is 18, which means D is 18 as well because they correspond. What is the measure of angle F? So we got 18 here, we got 90 here. Triangle angle sum theorem says all angles add up to 180. So 90 plus 18 is 108, which means F has to be 72, right? To subtract from 180. Make sure to make any mistakes. Yeah, that's good. All right. Wait. Let me just make sure one other thing. Measure angle F. Yeah, we're good. Okay. Which expression is equivalent to this? All right, so we are multiplying. Let's write it out over here again, even though it's a little waste of time, but just to show you guys how to do this. Z to the -1, Q to the 5th, Z, whoops, Z to the 3rd. Okay, now when we multiply, all right, this guy goes to this guy and multiplies. But I'm taking this in real time just for those of you guys who are new to the stream, so this is a real authentic test-taking experience. Explanations within the time limit. M to the 4th times M to the 1st, we add the exponents, M to the 5th. Q to the 4th times Q to the 5th, we add the exponents, Q to the 9th. Z to the -1 times Z cubed, we add the exponents, Z squared. And that's our answer. M to the 5th, 9th, Z squared. Let me just make sure I don't make any mistakes in transcription. We're good. Boom, done. Number 6. Ooh, box plots. Box and whiskers. Here we go. The box plots are mass kilograms, which following statement is true. Okay, so the median of group 1 is bigger. I wonder if it talks about median, because we don't know anything about the mean in a box plot. The median of group 1 is greater than group 2. That's that little line right there. Boom. The median of, yeah, they're just talking about median. This is the interquartile range, this box here. That's the minimum. That's the maximum. Range would be from here to here. So that's it. Graphs intersect at point XY. What is a possible value of X? You know what's so beautiful about this? This calculator is so phenomenal. So I'm going to try and show you guys just how to use Desmos. Really, really get comfortable with it. It's just awesome. Okay. Why can't I click? Okay. Y equals 76. Y equals X squared minus 5. Now, if we didn't want to do this by the calculator, we can, of course, do it by hand. But it's a little annoying because you have to scroll all the way up. But here's the line, y equals 76. And there's our intersection points. And it's saying, what is the possible value of x? So we see x can either equal -9 or +9. And we're done. And it makes sense because you plug in 9, it's 81 minus 5 is 76. So 9 or -9. Boom, done. So good. To estimate the proportion of a population that has a certain characteristic, a random sample is selected from the population. Based on the sample, it is estimated the proportion of the population that is a characteristic 0.49. Margin of error. Okay, so anytime I get a margin of error, I'm always like, okay, cool. So it can be 0.04 below. So I minus 0.04, which is 0.45. 0.04 above, which is 0.53. Okay, like this and like this. Based on this estimated margin of error, which the following is the most appropriate conclusion by proportion that has the characteristic. Oh, yeah, right there. See? Oh, like clockwork, margin of error. It is not plausible. The proportion might be, but we don't know for sure. It is plausible. Nah, not really plausible that it's greater than 0.53. Okay. And how many points do the graphs are given? No, this is beautiful. Once again, now, I can graph this in Desmos. If you're not sure, do it. But these lines have the same slope, 2, 2, and different y-intercepts, 10, -1, a.k.a. they are parallel, so they have no intersections. In the x and y plane, the graph of linear function f contains the points 0, 2, and 8, 34. Which equation defines f, where y equals f of x? All right, so it's a linear equation. We got 2 points, so we're going to use point slope like a legend. Here we go. And I like to stack the coordinates to find my slope. Check it out. We go subtract down. 2 minus 34 is -32. 0 minus 8 is -8, goes on the bottom. We got a nice slope of 4. C, therefore, is the winner. Also, we have the y-intercept, which is amazing, 0, 2. So we know that the y-intercept is 2. Boom, done. X over y equals this. Hold on. This looks interesting. X over y equals 4. 24x over ny equals 4 as well. What is the value of n? 24. But let's do a little bit more. I'm going to explain how I got that in a second. But Let's do a little bit of better. Let's do like actual substitution just to show you. The reason why I said 24 is because the 24x, I need 24y to get x over y, which is 4. But let's actually, in case that didn't occur to you, let's do it the straightforward way, a little nice substitution. Multiply both sides by y. X equals 4y. Plug and chug. Wait. Yeah. Okay. This is going to be annoying. 4y times 24 is 96y over, oh my God, I wrote 99. 96y over ny equals 4. Cancel. 96 over n equals 4. Multiply both sides by n. You see, nice little variable isolation. And then we divide by 4. Use your calculator if you'd like, but 96 divided by 4 is indeed 24. So there's two nice ways to do it. All right, here we go. 12. The function, W moles volume, liquids, milliliters, blah, blah. According to the model, what is the predicted volume draining from the... Okay, so this is an interpreting linear equation. They're basically saying, what is it, how much is draining? AKA, how much is it changing each second? And T is in seconds. Well, if we plug in 0, it's 300. Plug in 1 second, it's down to 296, meaning it's losing 4. Another way to look at it is the rate of change is just the slope. It's the amount multiplying the variable, and that's that. 13. Each year, the value of an investment increases by this of its value the previous year, which is volume function best models how the value of the investment changes over time. Wait. Okay, so it's very important. So if it just had 0.49% of its initial value or something, this would be increasing linear. But, oh, by the way, decreasing, let's get rid of that, right? Goodbye, because it says it's increasing. So that's nice. You got down to two options. But usually when it's a percentage increase of the previous year, that percentage is changing because the total amount is growing. So it's like it's not not linear. It's not constant rate of change. It's increasing exponential. Boom, done. 14. The solution of the given system equations is... Oh, okay. I'm going to show you again on the calculator. Actually, I'm going to show you two ways. I'm going to show you. I got plenty of time. So we're going to first show you the old school method, which I actually honestly is my favorite, and it's probably a little faster. But we're going to show you how to do this on the calculator as well. Sorry, a little elimination. We want to, actually, wait a minute. We want to solve for y. So I'm going to multiply the bottom one by -4. That way we can cancel out the x's. So then we got negative 24x minus 4y equals negative 288, I believe. So when we add this with this guy, the x's cancel out. Negative 4y plus y is negative 3y. Negative 288 plus 48 is negative 240, right? And divide by negative 3. Hold on, let me make some room. Divide by negative 3. Divide by negative 3. Boom. Y equals 80. Boom. Done. Wait. Yeah, 80. Okay. But now I'm going to show you how to do it on the calculator. So we got 24x plus y equals 48. 6x plus y equals 72. So they said the solution. That's the intersection point. Now you just got to look. Where do they intersect? Oh, my God. It's up here. And what's the y value? Boom. Desmos tells you it's so easy. It's 80. This calculator is a game changer, people. Okay, 15. The given equation relates the variables x and y. For what value of x does the value of y reach its minimum? Again, it's literally like with the calculator. It makes it so nice. But we're going to do it non-calculator first, just for fun. The minimum value, so for what value of x does it reach the minimum? That's the x value of the vertex, because this is a positive a value, so it's going like that. That's negative b, which is negative 14, over 2a. A is 1, so it's just 2 times 1 is 2. 14 over 2, which is 7. Okay, that's option A to solve. Let's go to our beautiful calculator, option B, x squared minus 14x plus 22. What do they want? What value of x? Look where the minimum is. And it's like shows up. Look, it's just boom. It's at 7. It's so good. All right. Moving on. Okay, 16. The function h is defined by h of x equals 4x plus 28. The graph of y equals h of x in the xy plane has an x-intercept of a, 0, and a y-intercept of 0, b. where A and B are constants. Okay, so we just find the intercepts. This is no problem. So they're telling us what to do. To find the x-intercept, plug 0 in for the function value, aka it's like y, right? So 0 equals 4x plus 28. Solve for x. Negative 28 equals 4x. Divide by 4. X equals negative 7. That's my A value, right? Boom. Then for the y-intercept, plug in 0 for x. That zeroes out. It's 28. Okay. That's my B value. And they want A plus B. Negative 7 plus 28 is 21. Boom, done. Square. We got a square in the mix. Square A has side lengths that are 166. Oh, we got 2 squares. Okay, see, this is one thing that I've noticed on this new version that's a little different. Like these weird numbers that I would never see on the original version. Like 166, come on. Square A has side lengths that are 166 times the side lengths of square B. So this would just be x, and those would be 166x. The area of square A is k times the area of square B. Okay, what's the value of k? So what is the value, the area, right? Well, it's a square, so all the sides are equal. So this one is just x squared. This one is, yikes, 166 times x times 166. So it's 1. So this one is 27,556 x squared. Will this even fit? 27,556? Oh, it does fit. All right. Okay, 18. Scatter plot shows a relationship between two variables, x and y. Line of best fit for the data shown. X equals 25.5. Which of the following is closest to the y value predicted by the line of best fit? Wait, what? At x equals 25.5. You can't annotate. Like, they let you annotate on the reading and the writing, and they don't let you annotate on the math. Hey, it is what it is. All right, so 25.5. So here's 25. Here's 25.5. Right there. Where's the line of best fit? It's right there. It looks like 8.4, maybe 8.3. I'll take 8.2. Close enough. Double check. 25.5. Yeah, I'd say that's fine. 8.2 is legit. That's that. Boom, done. 19. The measure of r is 2 pi thirds radians. Measure of angle T is 5 pi twelfths. Greater than the measure of R. So that's my R. And then it's adding 5 pi twelfths. And then we need the measure of angle T in degrees. So first, let's get common denominators. Multiply by 4 by 4. And we get 5 pi over 12 plus 8 pi over 12. And that's 13 pi over 12. Now, a couple things. I already know the answer C, and I haven't done the calculation. Because 1 pi is 180. So I know this is a little bigger than 1 pi. So 195 is the only thing that makes sense. But how do you do the actual conversion? It's 13 pi over 12 times 180 over pi. If you're converting to degrees, it's either 180 over pi or degrees to radians, pi over 180. But you know you're doing it right from radians to degrees if the pi cancels out, which it will here. And then that's it. 13 times 180 divided by 12. And I'll just show you up here. Oops. We don't need parentheses. It's cool. And that's it. 195, just like we said. Boom, done. Number 20. A scientist initially measures 12,000 bacteria in a growth medium. 4 hours later, the scientist measures 24,000 bacteria. Assuming exponential growth, the formula blank gives the number of bacteria in growth medium. R onto your constant p is the number of bacteria. What? Okay. What is the value of R? What? Wait a minute. I read it too fast. 12,000. Oh, got it. Understood. Okay, so the C value is my initial value. So that's the 12 G's, okay? And then the 2 is obviously it's doubling. R, wait, what? What's happening? Oh, it doubles every 4 hours. So R is 1/4. This is a weird question because, well, it does say T is the number of hours, right? So I'll put it to you like this. if I okay, let's think about it like this, right? We know that it's saying that in 4 hours it doubles. So you can kind of like try these different values. Like 1 over 12,000 makes no sense, but you could literally plug and chug with all of these. But the only thing that makes sense is 1/4, because if you try it out, right, you plug in 4, and it's going to be 4 times 1/4 is 1. 2 to the 1 power is 2. 2 times 12,000 is 24,000. So when you plug in 4 hours, you get 24,000, as you should. Then it doubles again at 8 hours, and it should go to 48,000, right? So you plug in 8. 1/4 of 8 is 2. 2 to the second power is 4. 4 times 12,000 is indeed 48,000. So this is one of my favorite ways to verify these types of exponential equations where you're trying to figure stuff out like this. Like, because it's not a typical exponential. Usually it's just this to the t power. Now they threw in this weird r value. It even threw me for a second. I was like, what the heck are they talking about? But anyways, r must be 1/4. Boom, done. Number 21. What is the small solution to the given equation? I mean, why can't we just use the calculator now for this? This is crazy. All right, so, I mean, I'll show you how to solve it algebraically too, but look, I'm just going to graph each side of the function like so. Oh, shoot. Sorry. By the way, to do the exponent, it's shift 6, just so you know. I've used Desmos like so much, so maybe I'm like more familiar with it than other folks, but I would definitely practice. So they want the smallest solution. Look, it's where they intersect. So it's two different spots. It's -3, because we're only looking at the x value, right? It's -3 and 10. So -3 is the smaller value, and that's the answer. Now I'm going to, and you can, remember, with this new test, you can put negatives in. Old test or current test or whatever, you cannot. But now we're going to solve it typical. So we're going to square both sides. X minus 2 squared equals 3x plus 34. We're going to FOIL this, x squared minus 4x plus 4, right? Why is that? Because x minus 2 squared is x minus 2 times x minus 2. And then you do your thing. Okay, and then we're going to use our nice zero product rule. We want everything to equal 0, correct? So we go boom, boom, and we go x squared minus 7x minus 30 equals 0. Then I'm going to factor, like we like to do, what two numbers multiply to -30 add to -7. That would be 3 and -10. And my two solutions are -3 and +10, just like we saw on the graph. The graph took like, well, actually they're about the same time. I don't know, whatever you prefer. Like this way, in my opinion, this thing is more satisfying. But yeah, whatever. Okay, which of the following are solutions to the given equations? Where a is a constant and a is greater than 3. Which of the following are solutions? This is weird. Let me think about it for a second. Where a is a constant and a is greater than 30. A plus 1. It's got to be a plus 1. Wait. It's 2. There's no option with just 2. Darn it. Wait. Why would it be a? Because then it would be 0. Wait a minute. If x is a, then it's 0 equals a minus 29, which doesn't make sense. If x, so 1 can't be right. It's got to be 2 and 3. But why? Oh, yeah, it is 2 and 3. Because 29 also works. Because 29, you plug it in and you get 0 equals 0. Okay, the reason why a plus 1 works is because, okay, imagine this. A plus 1, like you could just straight up plug these in actually, and you'd figure it out. A plus 1 minus 29, I'm plugging in for x, equals a plus 1 minus a times a plus 1 minus 29. So I'm just replacing all the x's. So these cancel, and then you just have a 1, and then you get, it's the same. So it's equal. So a plus 1 works, but that one I kind of like had an idea. So why does 29 work? So you get 29 minus 29 on the left side, which is 0. equals 29 minus A times 29 minus 29, which is 0. So 0 times anything is 0. So that's it. 12 minutes to spare, but whatevs. We're just going to move on. Now, if you're taking this test for real and you're not doing it like I do it, you should obviously use the time to check your work and do your thing. For me, it's all good. We're just going to check it. Now, they won't let me check it right now until I finish the whole thing. And I'm going to do the rest of the test tomorrow because it's getting late and I got to go to bed. But let's close this. And we're going to pause. How do I do it again? Save and exit. Cool. So we'll do this rest tomorrow. Let's see what people are saying. Hey, Vedant, you're welcome. Please make a video on how to use the Desmos calculator. Yeah, actually I can. It's a great idea. Hey, thank you, Akil. You're welcome. I hope you guys like this one in particular. Yes, it's possible to increase your score in 3 days if you like. It depends where you are and how much you practice. Like, if you kind of haven't done that much work at this point, yeah, you can do actually quite a bit in 3 days because you really need to get familiar with the test. So you could do a lot if you got the time. It's 11 p.m. Hey, you're in Vegas. My boy was in town from Vegas this weekend. Yeah. So no solution. So you're talking about two lines. So no solution is when two lines are parallel because the solution of a line or two lines is when they intersect. So if they're parallel, they never touch. That's no solution. One solution is the most common example where they touch at one point. They intersect, and that's just when they have different slopes. Infinite solutions is when they're literally the same slope, same y-intercept, because they're on top of each other, so they intersect an infinite number of times. That's that. Okay, guys, I gotta go to bed. It's late. It's 11:20, and I've been tutoring since 11:45 today, so it's been a long day, and I gotta go to sleep. Thank you guys so much for joining. I'll see you back tomorrow. I don't know exactly when yet, but I'm going to figure it out, and I'll blast it out on the Discord server. So if you want to know when the streams are, join the Discord server. That's where I kind of put out the bat signal for all you guys so you know what's what. And that's it. Have a good night. Thank you guys so much for joining, and I will see you in the next video.